How are you doing, Engineer Yahya?
I'm fine, thanks for asking. Just finished a work day today.
All right, let's wait for a bit and we'll start.
No worries.
And happy to see you.
Okay, let me just share my screen real quick. Okay, so you should all be able to see my screen right now. Okay, so welcome everyone. This is the CSWP preparation tips from an expert session. Um, I hope most of you have been part of the previous session that we had for the CSWA, the associate level exam preparation session. So this is for the next level. This is for the professional exam. If any of you actually attended the previous one and actually got certified, let me know in the chat. I would be more than happy to celebrate you all. But without further ado, let's just make sure to thank those who helped bring this session into existence. So all of the people working behind the scenes in the Addis Ababa SolidWorks user group, massive shout out to them because they're the guys who arranged all of this. Now, um, just to start real quick, I don't really want to spend a lot of time on this slide. Just gonna say that I've been using SolidWorks for quite a while, and throughout those years, I think it's like approaching 10 years right now. I have taken a lot of exams, like way too many exams. And what I'm trying to do now is to share my tips and tricks, share my 2 cents with others, so that if they have the know-how and the skills to take the exam, they just need to know a bit more detail about what the exam is and what it covers. This is what we're here to talk about today. Okay, so if you're more interested in my background as a SolidWorks user and my history with the SolidWorks community, you can check this podcast that I had with another SolidWorks user group leader, Prasad from India. He had this series of user group meetings, which were more like a podcast, less of a user group meeting. And we talked for hours on end about my history with the SolidWorks community. But enough of that, enough about me. We're here to talk about the exams. So let's talk a bit more about the CSWP. And this is our agenda for today. We're going to start by talking about what even is the CSWP. If anyone here was part of our previous session about the associate level exam, you notice the similarity in the structure. So we'll start by defining what that exam even is. Why should we care about it? Who is it for? Is it right for me or not? And how do I know if that exam is the correct level for me? Then we're going to start discussing some of the information about that exam, the topics that it covers, the commands that you must master before you take the exam, and so on. And then we're going to talk about some tips and tricks for you to take into consideration while taking the exam. And at the very end, we will end with um, some resources, like free resources. All of the resources that we're going to mention today are going to be free resources for you to check out and use in preparation for the exam. So let's start with the very beginning. What is the CSWP? And just like every other exam, as we've come to know, the name of the exam is the title that you get when you pass the exam. So in this case, Certified SolidWorks Professional. That is the title that you get when you pass the exam. And this actually indicates many things. It indicates that you're a certified user in a software which is called SolidWorks at the level of professional. So previously we talked about the CSWA, that was the associate level, and this is now the professional level, the next level. Okay, and even though we usually just refer to it as CSWP, there are actually many professional level exams. But this one, the one we're talking about today, the CAD design exam, is the most popular one. So that if you ever hear anyone saying, I'm a CSWP, he's talking about the CAD design exam, which was previously also known as the mechanical design. So what this exam covers is basically all of the different aspects that a CAD designer should master and should be knowledgeable about, whether it's part design, whether it's assemblies, whether it's configurations, and we're going to go through all of these things in a moment. But First of all, remember that now that we've taken a step higher from the associate level, we're now at the professional level. We should know that the requirements are now even higher. It's not just for a beginner as the CSWA was. The CSWA was usually tailored for students and beginners. This one is no, it's for professionals, as the title says. And the main goal here is, once again, a better representation of your skills, of your knowledge, of your expertise with the software and with the industry that you're in general, in this case, CAD design. So being able to read drawings and prints, being able to convey the information from a drawing or a print into the software and create a 3D model, a parametric 3D model, and so on. These are all different skills that are industry related that the exam will also test you on. And the summary of all of this is, it's just a very easy and quick way for you to prove yourself, therefore making it easier for you to get an internship if you're still a student, or get a job if you're already a graduate and you're trying to apply for a job. It just makes it easier for you to demonstrate your skills at a very quick pace without needing to sit down and show them your portfolio and show them all the designs that you've created. You might still have to do that, but this just gets you out of the way and just makes you one step ahead of everyone else. Okay, so it just makes you very easily showcasing your work in a timely manner. Okay, now if you go to the definition of what a CSWP is on the official SolidWorks website, it says that a CSWP has proven his ability to design. This is the first thing, and also analyze. And this is where the difference between just an associate and a professional comes, where you can see something and notice different details about it, and based on those details make a decision on how you're going to design it or how you're going to modify it later on. So not just to design, but also analyze your parametric parts and also your movable assemblies. And remember the keywords here: parametric parts, parts that can be easily edited in the future, not just something that you create now, and if you edit it later on in the future, you end up with a lot of errors. That's not a professional. A professional, every change that he adds or that he makes to his model is precise, it's calculated. And when it comes to assemblies, not just something still, something that can be a mechanism, something that can move around, and something that can be introduced into the real world and that you can actually use and manufacture, and it will work from day one because you're a professional. This is the whole end goal. And the way you're going to do all of this is through the variety of complex features in SolidWorks software. And when it says here complex features, it just means that, let's say, for example, in the CSWA exam, it was only covering like 10, 15, 20 commands in SolidWorks. We're now talking about like 30, 40, or maybe even 50 commands. We're making sure to test you in even more commands, even more details, so that you're indeed a professional in the software. Now, if you remember from the associate level exam, it wasn't really divided into any segments or anything, but it was just like a parts section and an assembly section all in one single exam. Now, with the CSWP, it's quite different. It's actually divided into three separate exams that you can actually take separately. You don't have to take them in order. You don't have to take them one by one. So I personally, I think I took like the second, the third, and then the first. It doesn't matter. As soon as you pass all three segments, you will end up with the certification. And if you, for any reason, didn't pass one of the segments, you only need to retake that segment on its own. You don't need to retake the whole thing. So these three segments are divided based on topics. Okay, and the first one, the first segment is the main topic, which is to create a part from scratch and then add some modifications to that part. So how did I get a better understanding about all of this? The main resource is always going to be the main CSWP webpage. So if you go to solidworks.com/CSWP, you will go to this webpage. And if you scroll down a bit, this is where you will find even more information about the exam. So it's going to tell you things like how long the exam is, what are the recommended trainings for you to take before sitting for that exam, other things. But something that I must note as well is, here is where you would find the sample exam. So here is where you can download the PDF for the sample exam, and we're going to get back to that at the very end of today's session. But if you scroll a bit down even more, you will find more details, things like what each segment is specifically testing you on, how long is that segment, and so on. And you've got segment 1, 2, and 3, and at the very end, this is my favorite part. You've got this whole list of every single command and every single feature in SolidWorks that the CSWP is going to test you on. And by the way, the list actually goes on and on. It's quite a long list, but once again, we're talking about the professional level exam. If you're taking this exam, you're putting yourself in a different level when compared to others. I think the associate level exam, we had like more than 600,000 certified SolidWorks associates worldwide. When it comes to professionals, it's only around 250,000, somewhere around that. It's not even 300,000. So we're talking about a totally different scale of people who have proven their skills through this exam and make it easier for themselves and for others to demonstrate their skills in a very quick and timely manner. Okay, so here's a very quick overview about the different segments that we have. The first segment, as I mentioned, it's just going to start by creating a design and then doing some modification to that design, right? So what you would need here is to start by the modeling phase, and you would find a lot of similarities between this part and the same section as it is in the CSWA exam in the associate level. The only difference is the difficulty. So the goals, the things that you have to have in mind, the checklist that you have in your mind, it's the same. The only thing that differs now is the difficulty of the questions themselves. And it starts by obviously reading the question, taking your time to take a quick glance throughout the question and understand what it actually wants you to do. And it's also really good idea to go through the whole questions. So if you've got like an exam which is like 10 or 20 questions, it's totally fine to go through all of the questions just to understand not just what the question you're going to solve right now wants you to do, but also what the next question is going to ask you to do, and what the next question is going to ask you to do, and so on. And based on the changes or the different questions that come later on, you would be able to have a better understanding of the best way to design the question that you have in hand right now. So if I know that for question 2, I'm going to modify the model in a certain way, knowing that before I even draw my first sketch is going to make it way easier for me to create my first sketch, taking into consideration the edits that come in the future. And once again, this is all to make it easier for me to change my model without having any issues or any errors or warnings or difficulties. So another thing to notice as well is that just like the CSWA, we have here the questions divided into something like sections, where the first question, the very first question, is actually a multiple choice question. So the answer is going to be one of these 4 selections or the 4 choices that you see on screen. But the next question and the questions that follow will actually be a numeric value that you have to enter precisely. So if you want to take it as a reference for yourself, it's really important to make sure that your very first question in that section is exactly the one of the 4 answers that you have in the choices, so that when you do any modifications later on, you build up on that steady structure. So your base is sound and strong, and any modifications later on will be built upon that correct base. If your very first answer is slightly off, let's say the answers are 10, 20, 30, 50, and your answer is 49, well, that means that there's still some work to do in your design. Go back again and modify it until it becomes 50 exactly, or maybe it's not even 50, it has to be something else. But the main thing here is to make sure that it's exactly one of the choices that you have, so that at least when you do any changes later on, you don't want the mistakes or the errors to build up on each other. And we're going to talk about the error, the margin of error at the end of the session, but remember, it's not a big one. For the CSWA, it was 1%. This time it's even smaller. So this is the first thing with questions. Just take your time to read the questions, understand what it's asking you to do. And then when it's time to get inside of SolidWorks, don't rush into creating your first sketch or your first feature. It's really important to take your time to set up everything correctly. I've personally been a victim of this, where I would totally forget about the units and I would design it, and then I would realize at the very end that I actually had to make it in a different set of units. And as you guys know, when you change the units later on, SolidWorks doesn't scale up your model to that new unit. It just does a translation. If you say this is going to be 1 inch, and then you change it from 1 inch to be instead of having the file in inches to be in millimeters, it doesn't convert into 1 millimeter. It actually converts into 2.54 millimeters. So it's or 2.54 centimeters, whatever it is. So it's actually doing a conversion. It doesn't keep the value and just change the unit. That doesn't make sense. It's not doing a scaling. But what you would expect is for it to do a scale. So in that situation, you might actually end up using the scale feature, which is actually what I used to do to save myself some time instead of having to redo the whole thing. So it's really important to start by making sure that everything is set up correctly, including the units. Okay. Now, after that, I would prefer for you to take some time and add all of the variables that your questions will offer you. And when it comes to variables, notice that the exam is not going to give you all of the numbers directly. It's going to give you some of them, some of the dimensions, but some of them will be through variables. So it would say that this extrusion, for example, is A centimeters long, or the diameter of this cylinder is X millimeters wide, and so on. So these variables A, B, C, X, Y, and Z, these are going to be variables that might be used in different areas in the same model, or that the exam is going to reference them and change them later on in other questions. So in this question, it's going to say A is 100, and the next question is going to say make A 120, and the next question make it 90, and so on. So change the value of A. So these are all different ways for the exam to test your skills in designing and modifying the model. And it's really important to make sure that you've got all of these different variables set up correctly. Well, you can create them as you go. While you create the sketches and the features, you can create the global variables at that time. But I personally prefer to make sure that I don't miss anything, so that I would put everything at the very beginning and would create all of these different global variables, put their values, and then I would go straight ahead and start putting my dimensions and referencing those global variables. And we're going to see how to do that inside of SolidWorks also in just a minute. But once you have all of that set up, now it's time for you to start designing. And here you have a choice. You can either go ahead and put your material as well right now, or you can put it later on in the end. I would prefer to do it right now. Once again, this is my setup phase. Just want to make sure that I have put all of the different information inside of my part or my assembly, and then I can go ahead and start my design, so that I'm 100% certain that I haven't forgotten anything. But unlike the units, if you add the material in the middle, in the beginning, or even at the end, it's not going to do any difference. It's just going to change the mass of the volume at the end. But it's not going to change anything whether you put it in the beginning or the end. The main thing is for you to set the correct material. I just put it at the beginning just to make sure that I've covered or I've copied all of the information from the question inside of SolidWorks. Okay, but when it comes to the design itself, it's usually going to start by, as we mentioned, looking at the questions, understanding the design, and then deciding where do I want to put my first sketch. And when it comes to sketches, it's really important to make sure that your sketches are fully defined. As Tutul Toby used to say, fully defined every time. And the reason we want your sketches to be fully defined is that if you change them later on in the future, you don't want the modifications to cause undesirable or unpredictable changes. So let's say, for example, you have a rectangle that you already have specified its length and its width and its location and everything. If you change any value, you know for certain how it's going to change and how it's going to look like after the change. But if it's underdefined, if you don't specify all of the dimensions or all of the relations or all of the information of its position and orientation and dimensions, you would end up with, when you change one entity, something else would change or something else might not change, and you can't really predict because you haven't really put all the information inside of the model. It's not just information at this point; it's actually more like intelligence. You're putting your thoughts and your design intent inside of that model, so that when you do a change, it changes or gets modified exactly how you want it to be. So it's really important to make sure that your sketches are fully defined. And there are many ways to see if your sketch is fully defined or not. The first or easiest way is through the status bar in the bottom right corner. As you can see over here, it says underdefined. This is while I'm editing the sketch. If while I'm editing the sketch, it becomes fully defined, it's going to change and say fully defined. Okay, and there's actually many different ways to figure out if your sketches are fully defined or not. Another way is through the feature manager design tree, which is usually on the left. For some reason right now it's on the right. So you see the difference between sketch 1 and sketch 2. Sketch 1 is fully defined, sketch 2 is underdefined. You see this minus sign between the brackets? That means that it's underdefined. That means that you can drag or click and drag some of the entities and they would move along with you. You still haven't put all of the information about their size, their location, their orientation, and so on. And actually, there's a fourth or a third way to figure out if your sketches are fully defined or not. If you know that, feel free to put it in the chat. It's more of a visual way rather than just reading the name of the sketch or reading a status bar. Okay. Um, so after you create your sketches, it's now time to create your features, and it's really important to make sure that you're building your features in a reasonable way, in a way that's easy for you to create, but also easy for you to edit and easy for someone else to come and understand. So this is now the time to sit back and take your time to think about what is the best course of action. This actually might come before the sketching as well, but when it comes to features, sometimes even the same sketch can be used in multiple different ways. Am I going to put everything as a single sketch and then do multiple features from that same sketch, or am I going to create separate sketches and every single feature has its own sketch? Or am I going to do a bit of both? Am I going to do one big block of material and then start cutting things away? Or am I going to start shaping every single feature as it should look like at the very end? All of these different scenarios should go through your mind while you're thinking of how you're going to design this, whether it's the sketches or even the features. And it's really important to take your time here, even if you take some time just looking at the model and thinking about it, because anytime you spend making sure that the model is designed correctly at the beginning is going to definitely save you a lot of time and trial and error and warnings and errors in the feature tree in the future when you go ahead and answer the remaining questions. Okay. Um, and Bikalu here is saying red color over references. Yeah, well, when you over define, this is when you have errors in your model. And in that case, yeah, you would end up with a bunch of red and yellow references. Red is for an error. This is something wrong. And yellow is usually for a warning. Hey, something's not right. Not wrong, but it's also not right. Just make sure to check this out. I would prefer to have no red or yellow in my sketches or my features. I want everything to be nice and tidy. Okay, so this is the first section, and let's actually take a quick break and and put this to the test. So here's an example. Um, Obviously, this design is going to be um, simple. So the CSWP exam is way harder than this, of course. But I'm just here to take you through my train of thought when I sit through something like this. So here it's asking me to create a block, which is 100 by 100 by 20, and there's a 15 millimeter through hole. 15 is the diameter, of course, located at the third of the block's width and the fifth of its height. And how do I know that everything is in millimeters? Because at the bottom it says that the units is in millimeter, gram, and second. So I know that my lengths are all going to be in millimeters. So if I head over here to SolidWorks, I can now think of the model and say, okay, how am I going to create this? So we start, of course, by a sketch. Now, I'm actually going to do something a bit different. So I'm going to select my plane. Let's actually go with my front plane. And in here, this is actually a fresh installation of SolidWorks 2026. So I don't have any keyboard shortcuts or any mouse gestures or any customizations added whatsoever. It's definitely going to slow me down, but I also want you guys to relate to this so that you know that this is not the best way to go. the best way to go is to actually add some customizations, and I'm going to show you why in just a moment. So let's start with the outline. It's a block that is 100 by 100 by 20. We're now on the front plane, so I just want to draw this 100 by 100. So I can go ahead and get my rectangle. And I know that if I click on A in the keyboard, it's going to toggle from this type to this type. So I can very easily go from this to this. If I click A once again, it's going to go from this to the next one, to the next one, and to the next one. So I'm just going to click A in the keyboard, and as you can see, it's now toggling. So it's very quickly an easy way for me to go to the next type of rectangles, which is the actual type of rectangle that I'm actually looking for to use. And I actually prefer to use them from midpoints, not from corners. And I will tell you why in a moment. So if I draw a rectangle like this, it's very easy for me. So if I want this to be 100 by 100, I want this to be a square, I can just box select from the corner like this, and just like that I've selected both of them, make it equal, and now I have all the uh, all of the sides equal to each other. Now all I have to do now is just add a dimension to one of these. So I can just click on one of those, and I see this preview over here. This is a new feature that we had in SolidWorks. So I can just click on this and then just enter 100. I don't even have to go to the smart dimension tool or all the way over there. Everything is right where I need at my fingertips. But there's actually another way to do this. So let me do this once again. Let me draw a rectangle. Let me click on A to go to the another type. If I click Shift on my keyboard, okay, so this is a regular rectangle, as you can see. If I click Shift on my keyboard, it's now stuck at a square. And this is another enhancement in 2025, where if you click Shift while you're creating a rectangle, now it becomes a square. And you see this this dialog box over there, or this dimension. It's actually asking me to enter a value. So if I just enter 100, okay, it's now going to save that value for me. And if I enter it in both of them, it's already going to add that equal relation for me. So these are all different ways for me to create the rectangle very quickly and very easily. Someone might actually say, I don't want to go all the way over there to get the rectangle. I'm actually going to use the S key. So if I click S on the keyboard, I can now search real quick. I can also get the rectangle just from here. I can search for it. And from there, I can do the same thing, click S on my keyboard or Shift on my keyboard to make sure that this is now an equal rectangle. As you can see, here's the equal relation. And then using the preview of the dimensions, I can also do the same thing, just enter the value real quick. And once again, I'm now with the 100 dimension. So now I've got the 100 by 100. Now what I want to do is do that circle. So let's go ahead once again and use this S key. Here's the circle. Okay. And I think this was like, what, 15 in diameter? So here's a 15. And just like that, I have added the value. Now, you might be wondering, how do I have these options to enter the value really quick and all of that? If I select anything over here, you would see this option, sketch numeric input. This is what makes me able to enter a value while I'm sketching, while I'm creating something. And this is the other one, the preview sketch dimension. This is which enables me to just click on something and then it shows me this highlight, like this one over here. And if I click on the preview, pardon, so if I click on that preview, I would be able to enter a value. If I click away, it's not going to add the dimension at all. So these are all enhancements in SolidWorks, but me knowing that these exist make it way easier for me to design and sketch as you just saw. So what I need to do now is to place this somewhere in the third of the width and the fifth of the height, right? So one way to do this is to get the dimension and put a dimension between these two. And then I can say, okay, this is going to be 100. Okay, so I can say this is 100. Just going to select the 100. As you can see now, it enters 100 divided by 3. Okay, and indeed, it's going to do what I wanted to do. It's now 33.33. But here's a question. When I change this 100 to, let's say, 120, it doesn't change. It's still 33, right? So if I want them to be linked together, I want to have an equation between them. Now I need to start by the equal sign. So the moment you enter the equal sign, you're now creating an equation, right? And a cool thing about the equation is now when I click on this, it doesn't enter the value. It enters the reference, dimension 1 at sketch 1. It's the reference of that dimension. So now when I enter divided by 3 and enter like that, you see this symbol over here? It's now an equation, and I can also verify that because outside of it over here, I also see this red equation symbol over here. So now, if I change this 120 back again to 100, this is going to update automatically to 33.33. So very quickly and very easily, I managed to do it like that. Now I can do the same thing vertically, or I can do it in another way. So let's say, for example, I want to use one of the cool features that not many people actually talk about, which is called the segment tool. So if I draw a line, just a vertical line from here to here, okay, I want to divide that line into segments, into different equal portions. So now let's go and search for the segment tool, okay? So here's the segment tool. It's not really widely used, and that's because if I click on this show command location and I'm not doing anything, SolidWorks is automatically going to go ahead and find that segment tool for me. As you can see, it's in insert sketch tools segment. So it's buried deep down over there, but it's actually a very powerful feature. So knowing how this works, I can actually go ahead and say, I want to divide this into sketch points. So in this case, I need to make sure that I'm one number under the value that I want. So if I want this to be 5 segments, then I need only 4 points because the points are the dividers of the segments. So when I enter 4, now indeed I have 1, 2, 3, 4, and 5. Okay, so I can now hit OK. And now I've divided this into equal segments. And I can simply put a relation between these two and make these two coincident. And just like that, I now have this circle at the third of the width and at the fifth of the height. Okay, so these are different ways, different methods that you can use to create something like this. Usually in the exam, you would stick to one way and do everything in that same way. I'm just here trying to demonstrate multiple different variations of creating these designs. Now, here's an interesting thing. What I want to do now is to create a boss extrusion, right? So what you would expect me to do is to go over there to features and click on boss extrude, or maybe even for do the S key, just come over here and hit boss, right? And then go to boss extrusion and so on. And maybe I have the shaded sketch contours option on, and then I can go ahead and use like contour selection tool to select this contour. And then over here, I also have the extrusion option. These are all different options that you can go through. But what I'm actually going to do is something very simple. I'm simply going to exit the sketch, either from here or from here. But notice, as soon as I exit the sketch, what happens is that it's actually going to take me into the boss extrusion command automatically. Now, does anyone know why that happened? Let me know down in the chat if you know why when I exit the sketch, it automatically takes me to the boss extrusion. Now, I'm going to give you a couple of seconds while I just enter the values over here. So this should be 20. And I prefer to make everything symmetric, so I'm just going to make it mid-plane so that it goes in this direction, exactly how much it goes in that direction as well. Okay, and I'm going to hit OK. And just like that, I now have my design. Now, I don't seem to see anyone in the chat saying why. So basically what happened is that when I started my first sketch, I didn't go here and create a sketch. What I actually did is that I actually went overhead to the features and created the boss extrusion. And then I drew my sketch. So SolidWorks remembers that you actually started from a boss extrusion, so that when I exit the sketch, it's now going to take me back again into that boss extrusion once again. And this is not just for boss extrusions. This is for boss extrusions, cut extrusions, revolves, whether it's a cut or a boss, sweeps, lofts, boundaries, anything that needs a sketch like that. As soon as you do the ordering right, it's going to honor something like that. So what you would expect it to do is, if you have the sketch, then you click on the boss extrusion, it's directly going to go ahead and extrude from that sketch. But if you don't have the sketch ready, well, in that case, it's going to actually prompt you. Here it is. You see this message over here? So this message over here is saying, go ahead, either select a plane to create the sketch or select an existing sketch. And what I did is I selected the plane. I selected the front plane and I created the sketch. So when I exit, it takes me back again to that feature that I started with. So I hope you guys learned something from this short workflow. Now it's really important to check if the design is correct or not. So I'm going to go to the evaluate tab. I'm going to go to the mass properties, and here it says that the mass is 196.47. Let me put this in the chat real quick so that when I go over here back again to my presentation, I can check real quick if I'm right or not. And indeed, it is 196.47 grams. So this, once again, it's a very simple design, but what I want you guys to take from it is the workflow that I go through in my head and how I divide that model into different steps, and how I go about designing every step of those, and the different tools that can make me a quicker or a better designer, as we saw a bit earlier. So this is the first step, and the next step is to modify, to change the model. And modification is going to be in one of two ways. You would either just simply change the value of one of the global variables that you use. Remember A, B, C, X, Y, Z, and so on? Instead of having it 100, just change it to 120. That's it. And if you set up everything correctly, and if everything is linked together in the right way, everything is going to update with no errors, and it's going to be like the quickest question that you would ever solve. It's going to take you like 10 seconds to see the new value, change it in SolveWorks, and update, get the new mass, put it inside the question, and hit submit. That's very quick, right? But if you didn't set everything up with global variables, then it would be a lot of manual changes and manual edits. That's it's going to have a much higher probability or chance of having a mistake, right? So why do that when you have a very quick and easy way to do it through global variables? Now, the other type of modification is going to be like design changes. You would go ahead, add a hole, add some fillets, remove this, add a boss, remove a boss, and so on. So we do some design changes to the model. And in this case, building on a structural or a parametric, a correctly parametric structure, a correctly parametric base model is definitely going to help you, where any changes to that base model or to those additional features will not cause any errors, will not cause any red and yellow. Everything is going to work just fine. So this is all part of segment one, where you would not just create the design, but also modify it based on the questions that you have. So let's take an example. Now it says, let's make that block 150 by 200 by 30. And that hole, that was a 15 diameter hole, now going to be 20, and it's going to have a 10 millimeter depth. And it's going to be located at the fourth of the width and the fourth of the height. So instead of the third and the fifth, it's going to be the fourth and the fourth. All right, so let's go back inside of SolveWorks and see how we can do something like this. So here I have my first mistake, which is because I didn't read all of the questions in the beginning, I designed this model in such a way that it would require me to go back and modify the sketches to make those changes possible, because that's the last thing I want to do. So for example, this width right now, it's actually 20, and you can see that real quick from the bottom over here. It's 20 millimeters. I need to make this 30. You know, all I have to do is just click on this, and over here you see this 20 millimeter diameter. I can or dimension. I can click on it, enter 30, enter, and just like that, I've changed it to 30. I don't need to go and edit boss extrude one or anything. I can do this very quickly from here. Same thing about this dimension, for example. This is 100. I want to make it 200. Just enter 200, just like that. It's now updated. But remember that 150 in height. Now, because I created this through relations in the first phase, or in the first part, I now have to go back and edit the sketch. And this is going to be more time consuming. So anyways, let's go ahead and edit the sketch for this model. And here's what I'm talking about. You see this equal relation? It now has to go because I now need to enter a different value for this height. So it has to be 150. So if I from the beginning had looked at all the questions, known that this square is going to turn into a rectangle later on in the future, I would have taken that into consideration, and I wouldn't have designed this through relations. I would have added a dimension, separate dimension for this. Okay, and now the last thing is this equation. I can simply double click, and instead of it being that value divided by 3, I'm just going to do it divided by 4, and just like that, it has updated. The last thing to do now is for the fifth in height. So a very cool thing about the segment is that if you right click on this on this relation, this equidistant relation, you can now go and see this one, edit segment points. Simply click on this, and it's going to give you the back that property manager, where you can now modify this. Instead of 4 be make it 3, just like that, it's now going to be 3, and now I can reattach this to that point. Or here's a cool thing, I'm going to do a couple of undos. So if I delete one of these points, any point, whether it's this, any point of these, that means this one, for example, it's automatically going to rearrange itself so that it's also equidistant. So if I delete this, automatically it becomes 3, and the 3 become equidistant along that whole line. So it's really, really cool, and really, really quick to make this change from 4 to 3, or to from 5 to 4, and so on. If I want to change or maybe add, in that case, I would definitely go ahead and do edit segment points and add or increase the number of points. But if it's a removal, I don't need to do that. I can simply select one of these, click delete, and just like that, I only have 2, which now divides this into 1, 2, 3. So I have now got it in thirds. Okay, so this is a very, very quick way to do something like this. Anyways, let's just hit exit sketch, and now we're back uh, into the boss extrusion. But remember, this boss extrusion, I also need to change it a bit. So if you remember, this right now is, if I'm not mistaken, it's 15, right? It needs to change from 15 to, I think it was 25, or maybe it was 20. I'm not sure. Let me check real quick. Yeah, it was 20 with a depth of 10. Okay, so yeah, let's go ahead and add this 20. But the depth of 10 thing is going to make it a bit hard. So I've made it a bit bigger, but to change the depth, because this was all in one feature, and in that feature, I simply use that inner contour. um, I'm not able to actually control whether it's using the whole depth for just the whole, or for the rectangle as well. I need to separate that. So in that case, I need to come back again and edit the feature, and make sure to select the whole rectangle, and then say, okay, I want this. And I'm not also going to do it mid-plane. I'm just going to do it blind, because in that case, I'm able to specify the depth of that hole. It's not going to be through all, it's going to be a specific depth. So I need to start from a certain location. Okay, so here it is, no hole, just the extrusion. And then I'm going to reuse that sketch and do an extruded cut of 10 millimeters. But this time I'm also going to do selected contours, and I'm going to select just that inner contour of that circle, right? So now I've ended up with the final result. But it took me a lot of time, because I didn't take into consideration how I should modify that design later on. If I had taken that into consideration, it would have been way easier and way quicker for me to do those changes. As we saw, everything from instant 3D, all these dimensions are already out here. I can modify them real quick. But either way, let's just check and see how we're doing. So the mass in this case seems to be this value. Let me also put that in the chat. It's 896.86. Okay, now let's go ahead and check to see if we're correct. And indeed, it is 896.86. Looks like I'm actually ready to be a certified professional. Once again, these questions, they're very simple, way simpler than what the real exam is going to test you on. But the goal here is not to prepare you for the exam, it's just to show you how I personally go ahead and think of a design challenge like this, or a design change like we just saw in this modification. I showed you the mistakes that sometimes I would do for you to not do them. Also showed you the tips and tricks that make me a better and a faster designer for you to follow as well. Okay, now let's move on to segment 2. So we finished segment 1, which is only part modeling and modification. But if I now move ahead to the next step, which is segment 2, segment 2 is all about configurations. So if you've never used configurations before, basically a configuration is a way for you to have a single file, whether it's a part or an assembly, and in that file you will have multiple versions of that design, multiple configurations. So maybe, let's say, for example, you have um, something like a water bottle, okay? And that water bottle has different sizes, but the design itself is the same. So whether it's a like a 330 millimeter water bottle, or it's like a 1 liter water bottle, or 1.5 liter, or a 5 liter water bottle, it's the same design. But the only thing that changes is the diameter, the height, and the inner volume, of course. So you can do that all in one design and then change certain parameters or certain values from one configuration to the other. And this is what segment 2 tests: your ability to create configurations, to read configurations, and to modify configurations. And to be able to do that, you're actually not going to design something from scratch. You're actually going to be given a design that someone else has designed, and you would be requested, or you will have to modify that design for them. So once again, you didn't create it, but you will have to modify it. And this is when it's really important to understand how designs work and how any step can affect other steps later on. So from the beginning, when it comes to configurations and design tables, there are some very important topics that you need to master first, that you need to be knowledgeable about, that you need to study and make sure that you understand them very well. The first thing is obviously going to be design intent. How is a model designed, and based on what was it designed? Was it designed because of this or because of that? But when it's going to be changed, how is it going to be changed? All of these different things, these are the design intent, the why behind the design. Okay, why did he make it like this? Why did he do it like that? All of this is called design intent, the intent behind the design. So you must really be able to understand the design intent just by looking at the model and going through the feature tree. And that helps you later on when you want to modify it, you would refer to that design intent and use it. The second thing that you need to learn is also design intent. And I think you guys have like a sense of understanding of what the third thing is going to be. It's also actually going to be design intent. And after you finish design intent, and design intent, you need to now learn design intent and design intent. And after that, you might take some time to, after you go through all of these, to learn a bit more about design intent, design intent, design intent, and design intent. Now, jokes aside, why is design intent really, really important in this segment? It's actually important in all segments, but specifically in this one, because once again, you did not create the design, someone else did. Imagine one of your friends gave you his designs and said, look at these for like 5 seconds and then change them in this and this and this way, and change this to be like that and change that to be like this and so on. So you need to be able to understand someone else's design and understand, if he created it in this way, in this sequence, then the best way to modify that design is in this way, and so on. And this is all, it comes down to design intent, understanding the why behind the design. Why did that guy design this model in this way? And based on that, how is it going to be edited in the future? So this is what you would end up with if you did not respect design intent, as some people might call them ketchup and mustard. Now, this red and yellow is not the kind of red and yellow that you would actually prefer or order with your takeout, because this is all a bunch of warnings and errors that indicate that something has gone catastrophically wrong with your design. You had not respected the design intent of the original designer, and therefore your modifications, your old changes have clashed with the previous designs that he has created. And the easiest way for you to like not end up with something like this is to understand the relations between a design and the feature that comes before it and the feature that comes after it, and the features that were used for that feature to be created, and so on. And we call these child and parent relations. So basically, a child uh, is affected by the parent, and the parent affects the child. So if you have multiple features, let's say for example over here, when you look at Revolve 2, so Revolve 2, it's the parent of some of these features and sketches, and it's got a bunch of children. So it also has all of these fillets and revolves and patterns and stuff. These are its children. So what you understand by that is that if any of the parents have changed, the revolve is going to change. If I change sketch 80, revolve 2 is going to change. If I change plane 6, revolve 2 is going to change, and so on. These are its parents. On the other hand, if I change revolve 2, then its children will change. Then the fillets will change. Then the revolve 3 will change. Then the mirror or the pattern. These are all depending on the revolve. So that's the difference between the parent and the child. When a parent changes, the child changes. But when the child changes, it doesn't affect the parent. And the way I got this, if I go back again inside of SolidWorks, so here's the model. If I right click on any feature or any sketch or anything, I can go over here to parent child. So this is where you would get the dialog box for child and parent relationships. And here, as you can see, for boss extrude 1, its parents are sketch 1, which makes sense. If I change the sketch, the feature is going to change. And it also depends on the front plane. If the front plane changes, the boss extrusion is going to change. And the origin, if the origin changes, also the boss extrusion is going to change. Because in the sketch, I've referenced the origin and I've sketched that sketch on the front plane. So these are all things that will affect the boss extrusion. On the other hand, if I change the boss extrusion, then its children will change. The cut extrusion actually depends on the boss extrusion. So in that case, if this changes, that will change as well. And this is not just for things like this. I can go to the sketch itself. So I can go to sketch 1 and say, okay, what are your parents and children? So I can see that its parents are the planes that it was created on, the origin, of course, and then its children will be the boss extrusion and the cut extrusion. If the sketch changes, all of these will change, right? So this is a very quick way to understand the relationship between a parent and a child in a feature tree. Now, this is a very short feature tree, so it's not really uh, showing much. But when you end up with a design that's that long, it's really important to understand what affects what. If this changes, what else is going to change? If I delete this, what else is going to be deleted? If I suppress this, what else is going to be suppressed, and so on. Okay, and there's actually another way, an easier way, a more visual way to see the child and parent relationships, which is what you see right now over here on the left screen. So on the left of the screen, you will see these arrows, the purple and the blue arrows. The arrows pointing upwards, the blue ones, these will indicate the parents, and the ones pointing downwards, the purple ones, these indicate children's. So just by hovering over revolve 2, I can very quickly see what are the parents and what are the children. And this is called dynamic reference visualization. So I can do this inside of SolidWorks. If I go back again inside of SolidWorks, I can right click on the very top over here, and here they are, dynamic reference visualization for a child and for a parent. Let me just zoom in a bit. So as you can see here, this is the parent one, and this one over here, this is the child one. So the moment I click on one of these, I can now activate the dynamic reference visualization. So in this case, if I just hover over one of these, as you can see now, I see the arrows that would indicate what are the parents and what are the children. So for example, here, cut extrude 1, it does not have any children, but it's got 3 parents. In this case, it's got sketch 1, the boss extrusion, and the origin, and so on. If I go to the sketch, it's actually referencing the origin and the front plane, and its children will be the other 2. So this is a very quick way and easy way to very quickly visually see the references between parts and features. But it's also worth mentioning that at some point it actually might get way too big, that it would be not something like this, where if you go all the way to the very start of the features of the feature tree, you would not have enough arrows to go through all of the things in the feature tree. So it would end up looking something like that. So sometimes it's actually better to go through the dialog box itself. I would prefer to use the dynamic reference visualization if it's like a short feature tree, maybe like 10 features tops. If it's longer than that, then I would use the dialog box, right click, child and parent. Okay. Now that's basically what we have for segment 2, because once again, it's mainly about understanding the model and then doing the changes, add new configurations, modify existing configurations. Whether you do it manually or you do it through Excel, through an Excel design table, it's totally fine. The main thing is being able to understand the model and change it later on. Now, segment 3 is all about assemblies. So this is going to be pretty similar to what you would see in CSWA exam, but a bit harder. So how is that going to be harder? Just like we saw with segment one, it was pretty similar to segment to like the start or the beginning of the CSWA, but the level of the questions are higher. Here's the same thing. So the main things on your checklist, you must start by identifying where the origin is going to go. The origin is usually going to be um, defined by a reference. So let's say, for example, you insert your first component. Usually, you would end up with something like this. It's going to be fixed in place until you right click and set it to be float. And you actually want to do that, because if you don't do that, then the reference is wherever you drag that component and put it in 3D space. But for everything to be precise, you need to know exactly where it is in relation to the origin. So I would prefer to either add some mates, or if it's possible, make sure that when you actually put it or insert it into the assembly from the very beginning, just make sure to put it exactly where you need it to be. If that's not possible, which is probably how it's going to be, then mates are the way to go. And speaking of mates, there's actually many different ways to add mates for that. But instead of making this a two-step process that you first have to set it to be float and then add the mate, you can actually make it a single step, so that when you insert the component, it's automatically going to be floating, not fixed in space. So if I go back again inside of SolidWorks, and let's create a new assembly real quick, what you would see here when you insert a new component, SolidWorks is usually going to default by making the first component fixed, right? And that's actually not something that we would want to have. So if you scroll a bit over here, let me just zoom in over here. As you can see, this part. So it says here, fix or float the component on insert. Now, by default, as you can see, it's set to only fix the first component. I would actually prefer to set it to this one, to float, always float. Never fix the components in place, so that I can always have that component and drag it around and put it wherever I want it to be, so that I can either put it as a reference to the origin, I can reference other things to it, and so on. I don't want it to be just in space. That doesn't make any sense. It needs to be referenced by something. Okay, so if you set it to be float, now as soon as you insert your first component, it's going to be floating. You can hold it, you can drag it, you can move it, you can add mates to reorient it or reposition it. And this is what is going to bring us to the next point, which is when it comes to mates, the very easiest thing is to add a bunch of coincident mates. Whether it's with the planes themselves, like the front plane with a front plane, top plane with a top plane, or right plane with a right plane, you can actually make it way easier by just a singular mate instead of three with the origins. So if you have the origin of, let's say, the assembly and the origin of another component, and you made these two origins together, SolidWorks will give you an option, which is the align axes option that you see in the checkbox over there. If you check that checkbox, it's going to put the three axes directly on top of each other, so that the y-axis and the x-axis and the z-axis of this will exactly match the other one. So this is basically like three coincident mates in one. And this is really useful if you are exactly sure that the x direction of the first component is going to also go in the x direction of the second origin, and so on. But if they would be like rotated or anything, in that case, you would have to do the mates manually. Okay, so either way, do it however you want to do it, but make sure that you actually put the origin exactly where the question wants you to do, because if you don't do that, you can have the whole assembly correct, but the references are incorrect. Okay, so where the model is in 3D space is incorrect because of the reference, because of the origin is not referencing it correctly. Now, the other thing is, when it comes to the CSWA, you're only concerned about the standard mates, these couple of mates, which was very simple. But because we're now professionals, we're now talking about the CSWP exam, so we're also going to deal with the advanced mates. We're talking about, there are actually some pretty cool mates over here. Not just the limit distance mates and the limit angle mates, which I really like, but also the width mate or the symmetry mate. These are two mates that I really also use a lot. And the profile center mate. Once you start using that and understanding how it works, you're probably never going to use any other mate other than that, because it's really cool as well. So yeah, once again, these are the different types of mates that you would be required to use throughout the exam. Not just the standard mates, but also the advanced mates. And at the end, when you add all of the components together and make sure that everything is working correctly, you now need to do the last thing and test it, test the movement. And when it comes to testing, in the CSWA, you would usually just use the testing or drag a component around just to verify that everything is mated correctly. But in the CSWP, because we're professionals now, you need to make sure that there is no interference between the components and each other. So look at this example, for example. This animation, it looks really cool and everything, and you might say that whoever designed this is a real professional, except when you take a closer look over here and see that there's actually a bit of an interference happening between two of these components. So this is something that you need to keep an eye out on during the exam. When you add certain components and mate them together, and you create an assembly, when you test the motion, you're not just looking for the shape of the movement that is correct, but also you're looking for interferences between components and each other, because these interferences will indicate one of two things. Either your dimensions are wrong, that's not going to be the case because you didn't design these parts. The exam will actually give you the parts, or your assembly has something wrong with it, or maybe it's intentional, who knows. But either way, make sure to understand how to observe and figure out where the interferences are, how to let SolidWorks tell you if there's an interference or not, and how to pinpoint exactly where those interferences are, and any details that you can get about those interferences will also be helpful. Okay, so now we finished the three segments. It's really important now to somehow tell SolidWorks or tell the exam that I actually have created the model correctly. I've actually assembled the components correctly. I've created the configurations correctly. How do I tell it that? And it's by answering the questions. And the questions will basically be one of two things. They either ask you about some measurements, or they ask you about some mass properties. So all of these will reside in the Evaluate tab, as we saw a bit earlier. So let's start with the measure tool. So this is the measure tool, or the interface of the dialog box of the measure tool, which is really intelligent. When you select like two faces that are parallel to each other, it's automatically going to tell you the distance between them. If you select two angled faces, it's automatically going to tell you the angle between them. If you select like a point and a line, it's going to tell you the normal distance between them. If that point is actually on that lines, maybe you're going to tell you that they're actually collinear or something. If you select two lines, it's going to tell you the angle between them or the distance between them, depending on whether they're parallel or askew or whatever they may be. So it's really intelligent. You simply select the selections, and it's automatically going to tell you what the values are of the possible dimensions. But as we also saw a bit earlier in the session, you don't actually have to do that. Sometimes when you simply select anything in the graphics area, it's automatically going to show down in the status bar with its value, whether it's a length, it's a normal distance, if it's an angle. In this case, for example, it's showing us an angle over there. So that might actually save you some time. Instead of having to go to the measure tool, simply select the things in the graphics area, and it's directly going to show you the value right there in the status bar. Now, the mass properties, it's a bit different because those don't show up anywhere except inside of the mass properties dialog box. And this is basically going to rely on two things. So mass in general, it's as we all know, the equation goes like this. We've got the mass, we've got the density, and we've got the volume, right? Any two of those will make it easier for us to calculate the third. So in this case, the question is going to ask us about the mass. So we need to provide the correct volume and the correct density. Well, the density comes from the material. So if you specify the correct material, that means that you specify the correct density. If you specify the wrong material, wrong density. But the volume is really interesting because the volume is only going to be concerned about the dimensions of your model. So if I create something that's 10 by 10 by 10, it's a cube, it's going to be a different volume than if it's 10 by 10 by 11, right? So even if it's the same material, but the same material is not going to be enough as long as I don't have the same volume. So to have the correct mass, I need to have the right volume, which means the right design, and the right density, which means the right material. If I do lose any of those, I'm going to end up with the wrong mass. Okay, so this is something to keep into consideration. Whether it's just like the mass, or maybe even the center of mass, where is the most part of the mass concentrated at? And in that case, you would need to have the coordinates of that center of mass, x, y, and z directions. And this is where it comes back again to the origin. If you don't have the reference correctly set up it's going to give you wrong measurements. So the origin is usually the default reference. Sometimes the exam will actually tell you to create a new reference, a new coordinate system, and use that as a reference. So you also need to know how to set up a different coordinate system and change the measurement instead of referencing the origin to measure the coordinate system that you created. So once you grasp that and do that multiple times, you'll now be able to not just do the design, but also prove to the exam that you've created the design correctly through answering the questions, whether it's the mass or the measurement or any other properties that it might request from you, right? So here's the summary. The first thing, which I actually mentioned at the beginning, the error margin. It's not big. For the CSWA, it was 1%. Here we're talking about 0.5%, 0.5%. That's the error margin. So if the mass, for example, is 100 grams and you answered by 99 grams, it's a wrong answer. If you answered 101, it's also a wrong answer. You only have half a gram to, or half a percent in general, but in this case, it's 100 grams to work with. This is why it's really important to make sure that whenever you have multiple choices, to get it exactly spot on, so that you don't get anything wrong. And the other thing is, once again, you have variables. These variables would change from one question to the other. Don't expect them to change the images as well. So don't rely on the images, rely on the dimensions, rely on the facts, rely on the values. Um, I've been told that some people actually take screenshots and overlay them together to see if they actually look the same or not. That's not going to work because it's not going to be the exact same global value, global variable value that the exam is using. The exam might put it 100, but in the question it says it's actually 110. So don't rely on the screenshot. Don't rely on the images. Rely on the values that it gives you. And the last thing, which is the most important thing, don't assume anything. If you think that this looks tangent, but there is no indication that it's tangent, that it's not. If you assume that this is not tangent, but there is no indication that it's not tangent, maybe it is tangent. Don't assume anything. Only rely on the data. If there's a dimension, use that. If there's an indication of a relation, add that. If there is none, then assume that there is nothing until you are proven otherwise. And this is really important because sometimes you might get convinced that, okay, this has to be set up in this way. And when you add those and start adding the other information from the question, you end up with an error because you actually over-define the model by assuming something that the question never told you to assume, right? So this is how it's going to be. We talked about segment 1, segment 2, and segment 3. We talked about the different parts, assemblies, and configurations. We talked about all of these different tips and tricks to go through. And what's really important now is to prepare you guys for the exam through resources. So when it comes to resources, I always like mentioning the free resources out there. There are many paid ones, but the free ones are the better ones. So I always advocate for the built-in tutorials that come with SolidWorks. So if you go to the help menu, there you'll find the tutorials. And the best thing about these are they're free, they're offline, they come with the example files so that you can instantly apply what you learn along with the lesson. And that's actually another cool thing that I actually need to show you so that you will actually understand how cool it is. So right now I'm here inside of SolidWorks. Let me just close this assembly real quick. And I've actually got a dual screen situation, so this might not work exactly how I want it to be. I'm just going to click tutorials. Yeah, it put the tutorials on this screen and SolidWorks on that screen, but no worries. So if I put this over here and get my tutorials next to it, let me just make this a bit smaller. So now if I go to, let's say, basic techniques, I want to learn something about maybe fillets, or you know what, let's learn something about yeah, fillets is fine. Let's go with fillets, right? So it's here going to tell me, okay, you can actually design the model that you want to create so that you can apply on, or you can click here and very quickly have that model loaded inside of SolidWorks and start creating the fillet, which is what you're here to learn. You're here to learn about the fillet, right? So here's the example file. Go ahead and start applying the features. So here it says, okay, let's click on that fillet command. Maybe I can't find it. I can't see any fillet command over here. So if I click on fill it in the tutorial, I'm not doing anything, but right there inside of SolidWorks, it's actually highlighting it for me, which is so cool, right? So this is not just for this part. I can go over here and say, okay, new. I don't know where new is. Well, there it is. It's highlighting it for me. Where's the extrusion? There it is. Where's the center point arc? There it is, and so on. It's linked, directly linked to SolidWorks, so that if I select something in here, it's going to show it for me over there. And it's got a lot of things covered, things from basic techniques of designing and sketching and stuff like that, all the way to advanced topics in animations, in simulation, in the configurations and design tables, in customizing SolidWorks, adding keyboard shortcuts and adding mouse gestures, customizing the toolbars. All of this is included in the built-in tutorials. Now, this is the first thing, but that's not enough because there is more. So the next thing on my list is My SolidWorks. Now, My SolidWorks, in case you don't know, it's exactly as the tagline says. It's your place for all things SolidWorks. Whether you're looking for CAD models, whether you want to search the community, whether you want to look for tutorials or content, you will find that all over here. So I can come over here, filter by training, and then say, okay, CSWP. Okay, enter. And now I'm going to be presented with all of the learning paths or the lessons for the CSWP. So I've got here the whole exam preparation course that I can go through with. So these are video tutorials, if you prefer those. And I also have the sample exam. So let me open the sample exam in another tab. So what the sample exam is going to cover is exactly what we're going to see in a moment, which is the solution of this exam, but it's actually providing you with step-by-step explanation. But the preparation course is more of if you want to get yourself ready to be a certified SolidWorks professional, these are the topics that you need to understand. You need to understand these things about sketching, these things about the features, and so on. So it's going to go through all of these. And obviously, as you can see over here, let me just zoom in a bit. Design intent, my favorite, right? So once again, this tutorial or this learning path, because it's got tons and tons of lessons that you can go through, these will make it better for you or make it easier for you to grasp all of the different commands that you would need to learn before you sit for the exam. And the sample exam is like, if I'm going to take the exam in like 2 hours, let's just make sure that I've got the right skills for it. So I'm going to go ahead and take that sample exam. So this is the first thing, which is My SolidWorks. Now, the second thing, which we just mentioned a bit earlier, which is the sample exams. So most exams, if not all of them, have sample exams. The expert level ones don't have the ones. The simulation exams also don't have sample exams. But other than that, pretty much all of the exams have a sample exam, which is made for you to have a better understanding about what to expect in the exam, what the style of the exam is going to look like, how are the questions going to be looking like, how are you going to answer, what do the answers look like, and so on. So for that, you would end up with a PDF like this one, for example, which once again, if you remember from the beginning of the session, if you go to solidworks.com/CSWP, it's going to you're going to find the download button for this PDF. So here I can scroll a bit down and it's going to tell me a bit more about the exam, how long it is, what each segment is about, how many points it can give me, all of the different topics or the commands that the exam would cover. Let me just zoom in a bit. And then if you scroll a bit down even more, it's going to tell you, okay, how to take the exam. So you download the virtual tester, you log in, and so on. We already know most of this. And here is the test questions. So here is where it tells you, okay, here's the model that you need to create. Here are the variables, as you can see, X, E, Y, and so on. And you're required to create this design using these reference images. Here's the question. So as you can see, it tells you what the units is going to be, tells you what the material is, and it also double checks with you with the density, because once again, volume and density, that's how you get the mass. And then here are the global variables. Put A as this value, put B as this value, and so on. And then here's some hints for you to take into consideration. And at the very end, here's the question. Measure the mass of the part. What's the mass? And here, once again, the first question is always a multiple choice one. So you have multiple choices. Make sure that your answer is exactly one of those up until the second decimal point, just like that. And then for question 2 is going to say, okay, just update these values. What's the value? No choices, nothing. You just have to enter the value correctly this time. do some more modifications, do some design changes, add this cutout, change this value, stuff like that, and then also get us with the new values. And at the very end here, you will find the answer key, which is for you to revise, to just to check that you actually got everything correct. All right. So this is the sample exam in a nutshell, and it's actually not just over. So if you scroll a bit down, you find some tips and tricks for you. So it's really worth checking out. And you also find some FAQs. So these are the questions that usually get asked by people who want to take the exam. Things like, what happens if I don't pass the exam? What would happen if the internet connection failed, or if my computer crashes? All of these different scenarios, you will find answers to them in this PDF. All right. So this is the second resource in terms of external resources for SolidWorks. The first one was obviously the built-in tutorials. We talked about my SolidWorks, talked about the sample exams, and then this is a shameless plug, Journey to the Certs. So if you don't know, I actually have published this. This is my journey through the CAD design uh, exams in general. So there are many different exams in here. We've got all the different professional advanced exams. We've got the associate professional and expert in CAD design. So each one of those is actually a separate article. So if I click on the CSWP, here's the article where it goes through that exam, basically what we did today, but in a written format instead of a video format like we're on live right now. So if you prefer this with links and with written tips and references for everything, if that's your thing, here is a reference for you to summarize or to do like a quick revision before you take the exam and go through everything. Obviously, it also has the resources at the very end of every single article. It always starts with the built-in tutorials, of course. And if I have like some YouTube playlists or something that I find interesting, I will also put them in here as well. So yeah, and here's how to a quick link to customizing your keyboard shortcuts and customizing SolidWorks in general. So yeah, this is one of many articles that I've written over the years for the exams, not just the professional exams specifically, but pretty much all of these different exams as well. So if that's something that you're interested in, um, give it a shot. Go through these written format articles, and then that would be pretty much mostly what we said today, but just in a written format for you to be able to come back later on. Okay. Now, when it comes to the CSWP, I think that you're now ready to go ahead and take the exam, and I'm really looking forward to hearing it from you guys after you take the exam, and I'm really looking forward to seeing a lot of mentions on LinkedIn, for example, for the Addis Ababa user group and all of the leaders, and me as well, if you want to, with your certifications, because I'd really love to see the output from today's session. So yeah, that's all for today. Now it's time for a Q&A. I will check the chat to see if there's any questions in there. And just in case I don't get to your question today, or maybe you have a question later on, this is my LinkedIn. I've got an open profile where anyone can send me a message directly. So let me know if you have any questions. Just go ahead and shoot me your message. If you attended this session, let me know so that I can get your feedback. If you have any feedback that you would like to share, it doesn't even have to be a question. It can be celebration of your new certificate, or any question related to SolidWorks in general, not just the exams. I'll be more than happy to answer your questions. With that out of the way, I'm now going to put the links that I mentioned in the chat. So all of the links that we just mentioned a bit earlier, and then I will go ahead and check the Q&A section for any questions that you guys have. Okay, I put all of the links in the chat. Leave them there for a moment so that everyone can check them. So I put the link for the CSWP webpage, the My SolidWorks, the Journey to the Search, and also my LinkedIn if you want to reach out to me. And now let me check out the Q&A. So here's the question. It says, what if we can't afford the full payment? Will there be some type of waiver? So this is a very good question. So I had another session. You can find it on YouTube, recording of it, called SolidWorks Animations, SolidWorks Certification, 101, which basically goes through the whole certification program, what it is, and stuff like that. And in the end, I discuss how to get exams for a discount or for free. Whether you're a student, whether you work for a company that has a license of SolidWorks, whether you're a maker, uh, all the different scenarios for you. So feel free to check that out. Once again, it's SolidWorks Certifications 101. I presented it at many different user groups, so you're going to find many versions of it on YouTube. But once again, at the very end of it, I discuss whether you're a student, how to get it through your university, if your university provides you with SolidWorks. If your university doesn't provide you with a license of SolidWorks, how you can get your own license for very, very cheap. And that would come with CSWA and CSWP vouchers. If you're a student, but your university doesn't give you one, and you also can't have your own license, how you can apply for certain like competitions that SolidWorks would regularly do, so that you can take these for free. Or if you're not a student, if you're a graduate, if you work for a company that has a license, all of the different scenarios, you can check that out. Here's another question that says, is there a way to edit the origin after the assembly? Yeah, of course. If the first component is fixed, simply float that first component, right click, float, and then you can basically drag it around and move it and reorient it or reposition it with new mates. If that first component is fixed in its position through mates, then you would need to modify or delete or suppress those mates first before you create new mate to reposition it. So it comes down to how it was oriented in the beginning. If it was fixed, then you need to float it first. If it was set up with mates, then you need to override those mates or modify them. Okay. Here's another question. It says, can you give details on this? From where can we access these sessions? If you're referencing the session that I just mentioned, SolidWorks certifications, it's on YouTube. Most of the sessions that I presented earlier, past couple of years, most of them are on YouTube. So simply just go ahead and search on YouTube, SolidWorks Certifications 101, Yahya Kheder or something. I'm pretty sure you're going to find them. If not, once again, feel free to reach out to me on LinkedIn. Let me know what's your case. Are you a student? Are you a graduate? Do you have a license? Do you not? And I would let you know the easiest way for you to get a discount or get certifications for free. And if I'm not mistaken, actually, I saw in the Telegram group of the Addis Ababa SolidWorks user group, there was actually a voucher code out there for 3 of the associate level exams. I think it was 3D Swimmer, 3D Swimmer, the Collaborative Designer for SolidWorks, and the Collaborative Industry Innovator. So things like that come all of the time. You would find opportunities like this to take exams for free. And by the way, if any of you is going to attend 3D Experience World, which is going to be on the 1st of February, this next February, like less than 2 months from now, there's actually going to be a free exam. I think it's 2 days to take exams for free, any exam for free at 3D Experience World if you attend there. And when I say any exam, even the expert level exam, which is like $150, it's going to be available for free. So if you're going to attend in person, make sure to register for that and take an exam over there for as well. I think they allow you to take like 2 exams, and after the event, if you take an exam at the event, you get like 3 more vouchers for other exams as well. It's an amazing opportunity for you to get certified for cheap. Here's another question. It says, for someone already comfortable with SolidWorks basics, what should be the main focus area while preparing for the CSWP? It's going to be speed and not thinking a lot before designing. So how can I make SolidWorks work for me? I'm not working for SolidWorks. I want SolidWorks to be the easiest tool ever. So customizing everything, having keyboard shortcuts, or maybe having mouse gestures, or modifying where the commands are on the toolbar, whatever works for you, but make the main goal is to be a faster designer. If you already know the tools, the next step is to make the tools work easier and faster for you. And that's one side. The other side is practice, because practice makes perfect. You will never be able to see everything, but the more you practice, the more you would see different designs and different ideas, and that's going to make it easier for you when you end up seeing a new design. You have this mental library of all of these different other designs that you've created and practiced on, so that you can learn from them and use them as a method of designing the new thing or understanding the new design that you're creating, whether it's in the exam or in life in general, for a work or for projects or whatever it is. But the exam is like the compacted version of it, so it's also worth mentioning here. But in general, speed, just customizing SolveWorks for your own use. And the other thing is practice. No matter how well you know what a feature does, the more you practice it, the better you will be at using it, the better you will be at understanding all of these niche scenarios, like the things we saw today. If I start the sketch, not through the sketch, but through the feature, then when I exit the sketch, it directly takes me to the feature, saving me some time. Things like that. These come through practice and learning. So make sure to try and grasp these as much as possible. Why get certified? That's a really good question. I think I addressed this already, but what I started with is it's a very quick and easy way for you to show others where you are. What level of SolidWorks skills do you have? Are you still a beginner? Are you a professional? Are you an expert? What topic are you an expert at? What topic are you a professional at? How long have you been using SolidWorks? All of these different questions, they can easily be answered through a certification. If I show you my CSWE, my expert level certification, you know for a fact that I can design in sheet metal, weldments, and I know how to create drawings and bill of materials and modify these and have these modifications updated. Why? Because the exam tests me in all of these different things. So if I pass the exam and I've got the certification, therefore I must have known how to do all of these things inside of SolidWorks. And the other thing is the industry knowledge. Some of these areas directly relate to industry knowledge that you need to know, not just the software that you're using. So, for example, if it's like let's take the CSWP exam for example. If you don't know how to read a print, how to read a drawing, and how to extract information from it and then create a model from it, you're not going to be able to solve the exam. Same thing for something like the sheet metal exam. If you don't know what the K factor is, or uh, how to do some bend deduction or bend radius calculation in the model, how the flat pattern even works, and why does the value differ a bit from the flat pattern value to the folded value or the folded state. Why does that happen? How does that happen? How to calculate something like that? If you don't have that know-how, you're not going to be able to solve the exam. Yeah, you have the software skills, but not the industry knowledge behind it. So this is also really important. So these are all different things that make it really important for anyone, me and you and all of us, to get certified. It's an easier way for us to prove our skills and to prove our knowledge in SolidWorks. Oh yeah, here's another new question. It says, from your experience, which SolidWorks features are most critical to master for clearing the CSWP exam? I mean, it all comes down to the way you design, because no two people design the same way, right? I might prefer to have everything in a single sketch and then create 100 features from that single sketch. That's my way of doing it. Someone else would say, no, I actually prefer to have a separate sketch for every single feature. And that's his way of doing it. So in my case, my skill is to master sketching because everything is in that sketch. His skill is to master all of the different features because he's doing all of these different features from separate sketches. So he's not really building massive sketches. He's building a lot of features. So he's building a lot of feature tree, a very long feature tree. For me, it's how to deal with this big sketch. So it differs from one style to another, but it all comes down to if you know how you design, focus on the features that you use mostly. And if there are features that you rarely use, maybe give these also some sort of attention, like the segment tool that we saw today. How many of you have used the segment tool before? I'd love to know actually in the chat. Let me know in the chat how many of you have used, not just known about, but used the segment tool before. And I wouldn't think that it's like, I don't think it's even going to be half of us or even the quarter of the attendees. Why? Because it's a niche thing, even though it's very powerful, but not many people use it. So if that's the case with you, then this is where you need to focus. These very niche features that will actually save a lot of time. I'm not learning this because it's a niche feature, because it's cool or anything. I'm learning it and I'm using it because it saves me time later on in the design process. So these are the things that you would need to focus on. It doesn't. It's not like one size fits all. It actually changes from one person to the other. But once again, this is how you would approach figuring out what works for you versus what works for anyone else. Okay, here's a new question. In the real world work environment, we're expected to download models from internet and detail them. Is this the best way for SolWorks' career journey? Not really. It depends on your career, actually. I mean, um, if you're like in R&D, for example, then you're actually in charge of coming up with the new ideas. So you would not actually create something that is like copycatting someone else. You would actually have to come up with a new invention, a new idea. If you're a draftsman, then all you have to do is just create drawings all day long and create the models from the drawings, and that's pretty much it. So it depends on what industry you're actually working in. So that's the first thing to tackle. What industry are you working in? What industry are you targeting if you're still not working, if you're still a student? After you finish that, or after you answer that, that's going to tell you which area or which direction to head to. But in general, I wouldn't advise you to put a lot of time and effort into just doing what other people did. So yeah, at some point it's good to learn from other people's models, but not all the time. At some point, you need to have your own creativity, having your own designs from scratch, learn it from them, do mistakes and fix them later on. But if all you do is copy other people's steps, step by step. So sometimes I would find like a 5 hour YouTube tutorial that it goes like, you have to click here and then you have to enter this value and have to enter this value. I'm not learning anything. I'm just copycatting. I'm just doing what he does. But I don't know why did he do it like this or why did he not do it in the other way. So this is a really important thing. But this once again comes down to the industry that you're working in. If your industry allows you for that much of innovation and trying different things, then that's definitely the way to go. If it does not, then it's still a good skill for you, for yourself, for your personal skills, but maybe not have 100% of the focus on it.
All right, Yahya, on behalf of SolidWorks User Group Addis Ababa, I would like to thank you for being with us for the second time. Just a quick reminder for everyone, all of our previous SolidWorks User Group session have been recorded and shared on our YouTube channel. So make sure to check out all the videos from Engineer Yahya and also from Prasad and James. So it will help you not only on just pass the exams, and it will help you on your career, or if you are a hobbyist or anyone that use SolidWorks as a recreational activity, it will help you a lot. So make sure to check out all of our social media. Once again, Engineer Yahya, thank you for being with us.
Always a pleasure.
So if everyone have any other questions, we'll wait 1 minute and we will close our session. And I would like to apologize to Yahya for not returning the DMs you have sent me 5 months ago. I will send you the link for the recording of all the sessions.
No worries, no worries. Totally fine. Have a nice day, everyone. Bye bye.
Thank you. Bye, everyone.